viewers, welcome to this video lecture series on computer networks. Today's topic of discussion is on a network layer protocol called address resolution protocol. So already on my channel I have posted video lectures on computer networks. The complete series is available. If at all any of the topics which are not included in the series and if request made by students, then I shall be including now. So this topic is a network layer protocol and it is called as the address resolution protocol. In my playlist that is on computer networks, if you remember, when I am explaining the network layer protocols, so I am writing here NL, network layer protocols. The main protocol was IP. Okay, so apart from IP, if you look into the other protocols that are there, one is IGMP, another is ICMP. Okay, so I have video lecture on IPv4, IGMP, ICMP as well. But apart from this, there are other auxiliary protocols, ARP, RARP and BOOTP. Okay, so the explanation for these protocols I shall be giving, and moreover what is the functioning of these protocols. In this session you will be completely getting the details of ARP, address resolution protocol, that is why this protocol is used, what is the packet format, and in which situations the services of the ARP protocol can be used. I shall explain you in detail now. Very simple way to start this explanation is in this manner, and also very simple way for you people also to remember the concept for ARP is in this manner. See, you have two systems, one is here, another is here. Now when these two systems communicate with each other, what is that is needed in the packet format apart from the data, the address for this. Suppose if this is the sender and this is the receiver, what the sender has to do, the sender is sending some message, some data to the receiver, but when it is sending data to the receiver, it needs what? The address of the receiver. Now when I say address can be of two types. One is the logical address and another one is the physical address. So it requires what? The logical address of the receiver, the physical address of the receiver. And the sender is also having its logical address and its physical address. So these four components are very much required here whenever a message is sent to the destination host or the target host or the target machine. This, suppose the sender is knowing its logical address, the sender is knowing its physical address, the sender is knowing the logical address of the receiver, but the sender is not knowing the physical address of the receiver. So this not knowing the physical address of the receiver, how without this it cannot, without this the communication is not possible. So for this reason only, the protocol that helps in resolving the address is called as ARP, address resolution protocol. It resolves the address problem. So that means it maps, what it maps, because it has to give the physical address of the receiver to the sender, it has to map logical address with the physical address. So the mapping of, this is what I have written here, mapping logical to physical. Logical address of the receiver is known to the sender, physical address is not known. So ARP is the one. If physical address is known to the receiver but logical address is not known, then physical address is known, logical address is not known, then RARP comes into picture. So this is also trying to give what this RARP is trying to give the logical address. It will map the physical address to logical address. And BOOTP also performs, it is similar to the functioning of RARP also. BOOTP will also try to map the physical address with the logical address. But there is a slight difference between the functioning of RARP and BOOTP. So these things I'll be telling you later. But now in this session, I shall discuss only about ARP. So I've put all the illustrations that are required for the functioning of ARP. If you are familiar with this kind of illustrations, then you are knowing the complete details of ARP. I have one diagram here. One is the system A and another is system B. This system A is the sender, system B is the receiver. Apart from system A and apart from system B, there are other systems also in the network. And sometimes the question arises, why do we require physical address when the logical address of the receiver is known? Is it not that sufficient for us to send a message? No, it is not sufficient. In computer networks, both the addresses are required. It is similar to our communication that we carry out by sending letters to our friends or relatives. Suppose I am staying at one place, place 1, and I am sending the letter to a person who is residing in place 2. The name of the person who is residing in place 2, let me take randomly, Mr. Gupta. Fine. Suppose if I am sending the letter to Mr. Gupta who is residing in place 2, how will the postal services come to know that they have to deliver this letter, because in that place there can be so many names with Mr. Gupta. It is not possible for the postal services to send that letter to that Mr. Gupta only. For that reason, what I do is I will write here house number, the area where, and the place. That means I am giving the other details also. Why? Because another Mr. Gupta may also reside in place 2, but his house number will not be same like this one. Even if the house number is same, the area will not be same. Both these Guptas are residing in this place, but definitely they are having their house address different. So you can always relate like this. This Mr. Gupta, whatever name we are giving here is a logical address. And without physical address mentioning in the letter will not reach the right person. Similarly, here also in communication, always when the sender is sending the data to the receiver's logical address and the receiver's physical address both should be known to the sender. If physical address is not known, then it will find out using the ARP protocol. If logical address is not known, then it will find out using the RARP or the BOOTP protocol. Okay, this is the definition or the introduction to ARP protocol. How it is going to get the physical address, that you will be learning in this session. So just look at this diagram. This is one LAN. Okay, that means I am telling this is in one network there are different hosts present. Fine. I'll just show here also, but I'm showing it in this way, in this particular form. So there is one system A and another system B, or machine A, machine B. Since machine A wants to send the packet to machine B. Look here, system A wants to send the packet to system B. So what it is doing, because it doesn't know the physical address of the system B, it is making a request. The request is what? Using the ARP packet. ARP packet we can send the request and we can receive the reply. So ARP request is made from the system A. It will send the request in the particular network. All the hosts that are connected in the network will receive that request. Suppose now this is system B, no, there can be system C, D, E. All these hosts will receive, but only the host system B will respond to that particular request. Why system B will respond? Because once it sees the packet, system B is checking that in that packet the logical address mentioned is what? Belonging to system B. So here I'll take what is that I have assumed? I have assumed that the logical address of system A is 130.23.43.20. The logical address of system B is 130.23.43.25. Okay, this is 20. Now this particular recipient, that is the receiver's logical address, if it is included in the ARP packet, definitely other host, when they see that the logical address does not belong to them, they just ignore. They are not going to reply. But the intended recipient, that means when system B sees that yes, this packet is having the logical address that is belonging to me, so let me respond. So system B will send a reply. But the reply is unicast. Unicast is what? One-to-one. It is sending directly to whom? Only to system A, not to other host in the system. It is not a broadcast reply, whereas request is broadcast. Request is broadcast, all the hosts in the network will receive. Reply is unicast, only the sender will receive, because the receiver wants to give the information to the sender, and in the reply it will mention its physical address. So here we are using the MAC address as the physical address, which is of 48 bits. We are using the hexadecimal notation to represent the MAC address or the physical address. So the reply has come. The request has gone. Look in the request what it is mentioned. I am looking for a physical address of a node with IP address 130.23.43.25. The reply is coming like this. The node physical address is A46EF45983AB. So this way the system A will come to know the physical address of the system B, and in future it will make use of this address, that is now it knows both logical and physical and will start communicating in future. When I am saying that the request is broadcast, how exactly it is working, that concept also I'll show you. Because we have here 5 layers, application layer is there, transport layer, network layer, physical layer, and the data link layer. So this is your physical layer, this is the data link layer, and this is the network layer. Now the ARP request has come from the network layer. It goes down, the below layer, the underlying layer is what? The data link layer. from network layer in the ARP request, it is mentioning that I don't know the MAC address. That means it is writing in its packet format the destination MAC address as 0000. Fine. But at the data link layer, what it happens is, because the data link layer deals with frame, and whatever packet comes from ARP, it has to get encapsulated in the frame. So this has come from where? This has come from the network layer. Now the header from the data link layer gets added. In the header, it is including what? The MAC address, that is the broadcast destination MAC address. That is the broadcast MAC address is included here. Broadcast MAC address gets added here in the header of the data link layer. Why? Because broadcast is needed so that all the hosts in the network should come to know, and whoever is having that logical address will only respond to that particular request. The ARP reply now is having what? Only unicast destination address. So how it works, unless you see the packet format, you may not be having the clarity. So let me explain the packet format also. This is the ARP packet format. In the ARP packet format, you can see these many fields are there, and it is of 32 bits. What are the different fields? The first field is the hardware type. Okay, hardware type, the value you need to mention here. So the type of the LAN. For Ethernet, the value is 1. So the value 1 gets included here. Protocol type. So here it is IPv4, and the value for this is 0800. So this will get included here. Hardware length. You are using a MAC address. So the hardware length will be having a value of 6 here. I am writing just in boxes the values. Then protocol length, you are using the logical address IPv4, which is represented by 32 bits. So we require only 4 bits here. 4 bytes are used to represent the logical address. So the value will be 4. Then what is the type of the operation? As I said, ARP is having a request and reply, both. So for request, if the packet is a request, then the value is 1. If the ARP packet is a reply packet, then the value is 2. These are the different fields. Then these 4 fields, definitely, as I said, what is that we require? Always for a system, sender, logical address, physical address. For the receiver, logical address, physical address. That means 4 values. So these are the 4 different fields. The sender, hardware address. Hardware address here is the physical address. The sender, protocol address. That is the logical address. Now the receiver's hardware address, which the sender does not know. If it is a request packet, then it is not filled. See, look here I have written. It is not filled in a request packet. Then what is the other one? The receiver's logical address. So these 4 fields are what? Only logical, physical of both sender and receiver. But if it is a request packet, definitely this particular physical address is not known to the sender. That's why we are not filling it. Now look at the same thing, just in an example, the request and the reply packet. I have shown it in one diagram. I'll focus there. So this part this is the sender, okay? This is the receiver. The sender is having a logical address of 130.23.43.20. The receiver is having the logical address of 130.23.43.25. The sender is having, this is the physical address, B23455102210. But the physical address of this receiver is not known. Now the ARP request comes from this and it goes to the sender side. That means here, this one. What is happening here in the packet format? I have placed in the request packet one sample, okay, sample values. You see here I have written it is an ARP request packet. ARP request comes from the sender and it is reaching towards the receiver. First field, this 0x represents, we are writing the values in hexadecimal notation. Now first one is, as I said there, hardware type. Hardware type for Ethernet, the value is 1. So that's why we are writing 1. Fine. Next is the protocol type. Since it is an IPv4, the value is 0800. This is what you have to remember. Next is the hardware length. Here the value you can see is 06 because 6 bytes are needed to represent the MAC address. Then for the protocol length, the value is 4. 4 bytes are needed to represent the logical address. Once again, you see here that field, the last field is the operation. Is it a request or reply? It is a request here. So the value is 1, okay, for request. Then comes the logical, physical of both sender and receiver. So the sender is writing its physical address, the sender is writing its logical address, but the sender is not knowing the physical address of the receiver machine, so it is 0000. The sender is writing the logical address of the receiver machine. Now the reply is coming here in the reply packet, ARP reply packet. Sample values I have shown here. These things will remain same. Which things? Hardware type, protocol type, hardware length, and protocol length. Now you see the request you are using the value 1. For the reply you have to use the value 2. Then comes what? See, now from this side when the packet is coming from B becomes now the sender and A becomes the receiver. That is why the sender values are placed first. Like here also the sender values are placed first. The sender value. Now this whatever I have written in the red color ink is the one which the host A was looking for. That means the physical address of this particular machine is sent here. I'll write the complete value here. 59 A46E F4 5983 AB. Okay, 83 AB. So whatever I have written in the red color font is the one that the host A was looking for, and it has come now from that host. B is giving its physical address. B is writing what? Its logical address. B is also including the address of the logical address of host A and logical address of host A and the physical address of host A. How it has come to know these two? Because while sending, the A has included its logical address and physical address also. So these two are definitely knowing now by B, and it will include in the ARP packet. So this is just one sample values for the ARP request and ARP reply. If a numerical is asked with certain values, and if they ask in the question to show it in a diagram the ARP request contents and the ARP reply contents, then you can include whatever values are given in the question, the logical and the physical address. You can include and show it in this manner. Now ARP is used in 4 different situations. 4 cases are possible. Then you must be wondering, how come 4 cases when the sender and receiver? We have definitely only 2 entities. One can be the sender and one can be the receiver. But we should also see that sometimes the receiver is not host. It can be a router. Sometimes the sender is not host. It can be a router. Sometimes the sender is host and the receiver is router. Sometimes the sender is a router, the receiver is a host, and sometimes both are routers. So all these 4 possibilities you need to look into it. I have the diagrams that are giving the explanation for these 4 cases. 4 different cases in which the services of ARP can be used. Case 1. Sender is a host, receiver is a host. Fine. That means the sender is looking for what? The sender is looking for the physical address that maps to the logical address of this host. Now we have case 2. In case 2, the sender is host but the receiver is router. So this sender is looking for what? It is looking for a physical address that maps to the logical address of this router. Then we have the third case. The sender is router and the receiver is also a router. So this router is looking for what? It is looking for the physical address which maps to the logical address of this router. Then we have the fourth case wherein the sender is the router but the receiver is a host. So here the router is looking for what? The physical address that maps to the logical address of this host. So these 4 situations you can still more easily remember with just one diagram, because you'll come to know practically where exactly these 4 cases will appear. See those 4 cases, how exactly it is read. This is one network A. This is one network B, or network 1 you can take. Network 1, network 2. Now in each of these network, what do you have? You have different hosts. Fine, like this, hosts are there. Now when one host from one network, that is network 1, wants to communicate with another host of network 2, it is possible through the router. So here this network is having what? Its router, that is the default gateway or the default router, and from this side you have this router. Okay, only via routers it is possible that the host can communicate with the host of other network. Now case 1, as I said, both sender and receiver are host, means both the sender is also here and the receiver is also here. Okay, within the network only they are looking for each one, the sender is looking for the physical address of one particular host. This is case 1. Okay. In case 2, host is a sender and the receiver is a router, this one. So here I can say this is the case 2 here. Fine, you can see sender is from this and the receiver is the router. Why it is looking for the logical address is because it wants to communicate with the host of another network, which is possible only through this router. So this router's physical address first it has to know, then it can further, this router will carry the further communication. The third case, as I said, both are routers, this one. Okay, these two routers. Sender is router, receiver is router. Fine. Finally, the fourth case is what? The sender is router and the receiver is what? Host. So this one. 4 possible cases are existing, and we say that ARP services can be used in this 4 different situations. So this is all about ARP. Hope you find this session useful. If you find it useful, please like, share and subscribe to my channel. Thank you. Bye bye and take care.